Hello, I welcome you all to this another interesting screencast. The problems read: the 50 kg port is supported from A by the three cables. Determine the force acting in each cable for equilibrium. Take D equal to 2.5 meters. The second problem reads: determine the height D of cable AB so that the force in cables AD and AC is 1/2 as great as the force in cable AB. What is the force in each cable for this case? The flower pot has a mass of 50 kg. Both these problems are coming from the Engineering Mechanics and Statics textbook, 13th edition by R.C. Hibbeler. So we have a system of cables here supporting a pot that weighs 50 kg in both cases. And in the first case, we're being asked to find the forces, the tension forces in each cable. And in the second case, we're being asked to find D, given that AD and AC is half the force the force in cables AD and AC is 1/2 as great as the force in cable AB. And later on, we're also being asked to find the forces in these particular cables. So let's draw the free body diagram, but before we do so, let's look at this particular problem. When we look at this problem, we realize one interesting thing. It is symmetrical about this plane. Can you see it? Of course. Okay. It's symmetrical about this particular plane, which is the ZX plane. Okay. So once there is symmetry, it means the problem becomes much easier, because we will know that AC is always going to be equal to AD. Great. Let's write down these particular notes. So we are saying the system is symmetrical about the XZ plane. Okay. Therefore, because of symmetry, we expect AC to be equal to AD. Okay. What else? And then we are going to take, of course, A is already the reference there, so there is nothing to talk about there. So let's draw the free body diagram quickly. Let's section these cables. So if we are to section them, right, then we expect a force in this direction, I mean the weight, they are like so, and then the tension forces, so we expect a tension force there and another one there. Okay, to equilibrate that, one there and another one there. Okay, tension force there and another one there. All right, so there we go. We have these tension forces like so. Let's label them. So this is going to be equal to AD. This is AD as well. This is AC. This is AC as well. This is AB. This is AB as well. This is the weight, and this weighs 50 kg. So I mean, this pot has a mass of 50 kg, you need to convert it to the weight, so multiply it by the acceleration due to gravity, so 9.81. So when we multiply, we get as a 50 by 9.81. What do we have? We have a 490.5 newtons. Great. So before we go further, we need to find the length. This particular problem, you can either solve it using the vector or the scalar approaches or the combination of both. Okay, for me, I'm going to go for the scalar. All right. Let's find the magnitudes of all the cables. The reason we are doing that is because we want to use those magnitudes to compute unit vectors or slopes in the x, y, and z. So let's start with AB, length AB, using Pythagoras. Length AB, this one is just in a single plane, which is a x, z plane. So we have, in the x, we have 6 squared, plus in the y, it is just 0. Then in the z, we have a d. Okay, we have a d. All right, we have a d, and then d itself in our case, okay, we'll leave it like this. We have a d. So we've been given, so this translates to, let me finish it off. This translates to a 36 plus d squared. Okay, all right. So d squared, and then let's find the other length, which is AC. AC, what do we have? In the x, we have a minus 6 squared, plus in the y, we have a minus 2 squared. In the z, we have a 3 squared positive, and this gives us 6 squared plus 2 squared plus 3 squared. That's C. Root of 49 is a 7. So we expect a 7 even in the length D. This one here we remove, it's not supposed to. Okay, just AC. This one also, it is we have a minus 6. Then there we have a 2 positive. Then we have a 3 also positive. This is also equal to 7. So we are done with everything. What we need to do now is to work out the forces. Let's start with AD. So AD, we are going to have a component in this direction like so. We'll have something like this, and then we'll also have something like this. All right, and then let's see, we'll have in the x-axis, we'll have something like this. Let me make it longer, or we can, okay, I'll make it longer like so. And then we'll have something like this in the y. And then we'll have something like this in the z. And then for the other one, we'll also have in this direction like so. We'll have in the x a negative, and then we'll have another one in this direction, just Let me just write this somewhere. This AB. So we are saying this is AB. Okay. So say we have a component also in this direction, and then we'll have a component along the Z axis. So let's label this. So this one is going to be equal to this one is equal to AB by what is the length along the x-axis is a 6, and what's the hypotenuse or the length? We said for AB it is 36 plus d squared. Alright, and then this one we say this AB by d divided by root of 36 plus d squared. Right. What else? Let's go to AD. AD, this is going to be equal to AD by the x-axis is 6 divided by the hypotenuse, which is a 7. And then this one, AD by in the our y it is a 2 divided by a 7. Then AD along the Z it is a 3, right, divided by a 7. Then we go to AC. AC it is along the x is 6 divided by 7. So you can think of this as unit vectors, right? Okay, these ratios, okay, giving us the direction or the slopes. AC, so this is AC by the length along the y 2 divided by 7. And then this one we have AC by the height divided by 7. So we have everything that we need. Maybe let me write this. So I just so this one is just AC. This is AC by length along the x-axis, which is 6 divided by 7. Alright, so we're going to sum this up using the equations of equilibrium. Alright, so say summation of forces in the x equal to 0. So in the x, what do we have? In the x we have let's start with AB, of course. So this is 6 divided by root of 36 plus d squared, okay, times AB minus 6 divided by 7 AC minus 6 divided by 7 AD equal to 0. Then we have summation of forces in the y equal to 0. What do we have along the y? We have 2 divided by 7 AC minus, then plus 2 divided by 7 AD equal to 0. Then we have finally summation of forces in the Z. What do we have? In the Z we have AB, we have D divided by root of 36 plus D squared times AB, and then we have plus 3 divided by 7 AC plus 3 divided by 7 AD. Then we have a minus 490.5 equal to 0. Okay, there we go. I just move it a little bit back like so. Alright, so we have all these equations. So we know that from this equation here, we know that we know that AC is equal to AD, right? And we know due to symmetry, okay? This is something that we knew. So this, if this is the case, then we can replace this here, okay? And replace this one there, and then solve these equations simultaneously. Okay, let's do so. So if we did so, then this becomes a 6 divided by square root of 36 plus D squared AB minus 2, so this becomes a 12 AD divided by 7 equal to 0. We do the same there. We have a D divided by root of 36 plus D squared AB plus 6 AD divided by 7 equal to 0. Alright, so now what we'll do is we are going to go to our case. That is case, we can work out this before I move to my case, to the case. So we can work out these two. We'll multiply there by 6 and here by 12. Okay, and then we'll sum them up. Okay, so if we did so, then we expect the following. If we did so, then we expect the following. We expect the following. Then we are going to have 6, that's 36. So we have a 6 by 6 plus a 12D. So we're going to have this equation. I don't want to replace D because I want to use these equations for two cases, right? I'll replace later on. So we'll have a 36 plus 12D divided by root of 36 plus D squared equal to these equations, here we expect a different number. Let me write this properly. course, here there is a 490.5, right? Alright, so we had a 6 here, we had a 12 here. Okay, so this is going to be equal to a 490.5 by 12. Okay, so this is a 5886. So we have this equation. We have this equation. We have this equation. So now let's go to case. We go to case 3-52. Okay. So in this particular case, we've been told that D is equal to a 2.5. Okay, D is equal to 2.5. This is not written well. This is like so, then times AB. Just 1 minute. We are multiplying by AB, so we can say like so, by AB equal to 5886. Okay. All right. So given D is equal to 2.5 meters for the first case, we can replace D in this equation. We can place it here, and we can also replace it there. Okay. So if we did so, then we'll find that our AB is just going to be equal to, let's do that. So we have 36 plus 2.5 squared. Okay. Square root of that is 6.5. Okay. Then we have 36 plus 12 by 2.5 divided by that. Okay. Then 5886 divided by. So we have AB equal to 579.68 newtons. Okay. You work it out again. 36 plus 12 by 2.5 divided by 36 plus 2.5 squared, and then 5886 divided by answer 579.68. Okay, that is AB. So once we found AB, we can find AD and later on find AC. So we are going to use this equation to find AD. So let's find what AD is. So AD therefore is just going to be equal to, let's plug in the values. So I have root of 36 plus 2.5 squared, which is just 6.5. So 6 divided by 6.5 times AB, which is 579.68. Okay. And then divided by 12 divided by 7. So this gives us a 312.14 newtons. So 6 divided by 6.5 times 579.68 divided by 12 divided by 7, 312.14. Then we find what AC is. Finally, we can find AC, and AC is, we can use this equation here. Okay, there are a lot of options, right? You can use that equation there. Let's find what AC is. So this is 2 over 7 times 8D, which is 312.14. Okay. Alright, we know that sorry, we know that AD is equal to AC, so there is nothing like calculating, right? I almost forgot. This is 312.14. Alright, so we are done with the first case. Let's go to the second case. Let's take case 3-53. Okay, 3-53. So we know that AC is equal to AD, okay? But we've also been told here that the force in cables AD and AC is 1/2 as great as the force in cable AB. So this is equal to 1/2 AB. So let's pick one equation that we can use here. Let's say we pick this one. Okay. So this one we are going to write it as 6 divided by root of 36 plus d squared, okay, by AB. Alright, and then minus we can even say equals to, we take the other side, since AC and AD are equal, this will be 12, and then AC we said is equal to 1/2 AB, so we replace this 1/2, it becomes a 2 by a 7 AB, like so. Okay, so this and this we can cancel out, and then we have just a 6, we have a 12 root of 36 plus d squared by a 6 by 14. Then we square both sides. Okay, once we square both sides, then we'll have 144 by 36 plus 144 by d squared equal to 84 squared, right? 6 by 14, 84. And therefore we have d squared, d, making this subject a formula. We will have both negative and positive, but we are looking for just a positive value. D is therefore equal to, so grab your calculator and do your calculations. This is going to be equal to 84 squared minus 144 by 36 divided by 144, root of that, then we'll have a 3.61 meters, right? Therefore our D is just going to be equal to 3.61 meters. Alright, so since we have D, we can find what AB is. We need to find all of them. Once we find AB, then we can find AD. We are using this equation, this one here, which is already simplified for AB. We already know what AD is. We already know what D is, rather. So we just replace the D. So we have 36 plus 12 by 3.61 divided by root of 36 plus 3.61 squared. Okay, and then we have 5886 divided by answer. It gives us a 519.61 newtons. Just repeat, 36 plus 12 by 3.61 divided by root of 36 plus 3.61 squared. Okay, 5886 divided by that, 519.61. Since we know this relationship here, this one here, it is half the value, so therefore AC is going to be equal to AD, which is just equal to half this, right? Therefore, AC is just equal to AD, which is equal to just half that is a 259.81 newtons. I think this is about it. So we have all the forces in the three cables, okay, and then we have D, okay, in the second case, given that the force in cables AD and AC is 1/2 as great as the force in cable AB, and then we calculated the force AB, which was this one here, and then AC and AD we have also calculated, since we are saying is 1/2 that in AB. Alright, I think this is about it, and I hope the video was helpful, and if it was, give me a thumbs up, like my video, continue subscribing and liking my channel. Bye bye, see you in my next screencast.